So you should get that several structures of the aldotetraos can occur. Okay, and apart from this, you can also have this tetraos. That is 4 carbon atoms. So 1, 2, 3, 4. You can bond them together. Okay. And here we can have now the oxygen, hydrogen. Here we can have OH. Okay. Here we can have the H. And here we can have the H. Here we can have the OH. And here we have CH2OH. So you see, these are aldotetraos. This is also also a aldotetraos. Okay. So apart from this, another one can occur. You can also have 1, 2, 3, 4 carbon atoms. Okay. I bonded that way. Then you have now the O here. You have the H. Okay. Then here we can have the H. Here we can have the OH. OH. Here we can have the OH. Here we can have the H. CH2OH. You see, they are all different. Okay. But all of them are still aldotetraos. Despite being different, they are still aldotetraos. You see that? Yeah. So we can have several aldotetraos. Just like we said, you can have several ketopentases. Yeah. But still, there is something that must differentiate them. Okay. Remember I told you about the L and D sugar. D sugar, you get that the hydroxyl group on the second last carbon is to the right. Okay. Like now, this one over here will be a D. So this one will be D aldotetraos. But for this one, we have the OH to the left. Okay, the second last OH to the left. This one will be a L aldotetraos. And how about this one? This one is also having the OH to the right. So this one will also be a D aldotetraos. Okay. Yeah. But still remember, even though this one is a D aldotetraos, also this one is a D aldotetraos, they are still also different. Okay. Yeah. So the L and the D sugar enables us to differentiate them in terms of the placement of the OH group on the second last carbon. Okay. On the compound. Yeah. So that is how it was to be done. That is how those examples were to be done. Also how to draw them, or even how to create them using the picture projection. Now, remember that I told you that the least amount of carbon atoms that can be carried by sugar is 3 carbon atoms. Okay, and now remember that one is now the triacid. The triacid. So the triacid, this is the simplest. Okay, monosaccharide. Okay, this is the simplest. In that it carries the least number of carbon atoms that can be carried by the sugar. Okay, that is 3 carbon atoms. Let's first draw how a triose looks like. Okay, and this can occur in 3 ways. Okay, so by number 1 we'll be having the D triose. Okay, and we can also be having the L triose. Okay, L triose, which is now the aldehyde. Okay, on the aldehyde. And also remember that we also have the keton. Okay, we also have the keton from the 3 carbon atoms that are forming the sugar. And this is how they will look like. So let's start with the D. The one for D. So we have the 3 carbon atoms. So 1, 2, 3. Okay. Here over here we have the oxygen. We have the hydrogen. Okay. Bonds are there. Then over here we can have the OH. Okay. Here we have the H and CH2OH. Okay. Yeah. So that's the first one. We can also have 1, 2, 3. Bodies are there. O, H, H over here. OH, 2, OH. Also we can have CH2OH. Okay. Carbon here. Then you have the O. Then CH2OH. You see how they are? Here we have the H on this side, but here we have the OH on this side. Okay. Like here we have the OH on the second last carbon to the right. Okay. And over here we have the OH on the second last carbon to the left. Okay. But now this one is now for the keton functional group. For the triose, it is known as glyceraldehyde. Okay. Glyceraldehyde. Okay. Like now over here now we'll be having the D D-glyceraldehyde, okay? And this other one will be having the L-glyceraldehyde. Then the last one over here will be having the dihydroxyacetone, okay? Dihydroxyacetone. Over here, this one is known as the dihydroxyacetone. This one is known as the L-glyceraldehyde. So we have the D-glyceraldehyde, the L-glyceraldehyde, and the dihydroxyacetone. Okay. Now these ones are the trioses. And now we specified them. We have the D-glyceraldehyde, the L-glyceraldehyde, and the dihydroxyacetone. Okay. But now all of these, they are still the trioses. Okay. They have 3 carbon atoms. They are sugars with 3 carbon atoms, which is the least number of carbon atoms that can be carried by the sugar. Okay. They have 3 carbon atoms each. Okay. Then these ones are having the functional group, the aldehyde functional group. But now this one is having a ketone functional group. Okay. Now this one is a ketose, but these two are aldoses. Okay. And now the aldoses have been differentiated further through the positioning of the hydroxyl group. Okay. Whereby now we are having the one to the right with the hydroxyl group on the second last carbon to the right. That is the D sugar. So it is D-glyceraldehyde. And now the one that's having the hydroxyl group on the second last to the left, that is known as the L sugar. Okay. Now we have the L-glyceraldehyde. But now this one over here, which is the ketone group, is known as the dihydroxyacetone. Okay. Dihydroxyacetone. I believe that now you can see on the trioses, the trioses are existing in 2. Okay. We have the D and the L. Now this one will lead us to discussing something that is known as the stereoisomerism. Okay. Stereoisomerism. Okay. But now we'll be talking about the isomer. I believe maybe you've come across the word stereoisomers. Okay. And you want to know that what are these? Okay. So get that stereoisomers, I believe you can see what you're having here, right? Stereoisomers, they are isomers, okay, that have the same structural formula. They have the same structural formula, but different in the arrangement of atoms. Okay, atoms or groups in 3-dimensional space. Okay, so it's either in 3 or even in 2-dimensional space. They are having different arrangements, but they are similar. Okay, they have the same structural formula. The same structural formula in that they are having the same number of carbon atoms. They are having the same number of hydrogen atoms. They are also having the same number of carbon atoms. They have the same number. But now when it comes to the arrangement, in either in 3-dimensional or even in 2-dimensional, get that now they differ. Okay. Like now, when you check this one over here, okay, let's check on the tribes. Okay. Look at this one and this one. These ones are having the same number of carbon atoms. Okay? They're having the same number of carbon atoms. They're having the same number of hydrogen atoms. They're having the same number of oxygen atoms. But now, we get that the arrangement is where now they differ. Okay? Like for this one having the hydroxyl group to the right. But this one having it to the left. Okay? They are isomers that are having the same structural formula, but differing in the arrangement of the atoms or groups in the 3-dimensional or even in the 2-dimensional. Okay. So, if you come across 2 molecules that are having the same structural formula, okay, they're having the same structural formula, but they cannot be superimposed in that they are not identical. They are non-identical. Then those isomers are known as enantiomers. Okay, they're known as enantiomers. So enantiomers, get that they are non-superimposable. Okay, they are non-identical. In that, let me put this one from this side so that you can get a good view of them. So 1, 2, 3. Stereoisomers that are having the same structural formula. Okay, that is, they have the same number of atoms present. Okay. And they are mirror image of one another, okay, but they cannot superimpose in that they are non-identical, okay. Like you see this one. When you take a mirror, okay, and put a mirror right here, you'll get that this one here is the mirror image of this, but they are non-identical in that they are not similar, okay. The same applies to this. When you take a mirror and put it here, okay, you get that this one over here will be a mirror image of this one, but they are non-identical, in that you cannot take this one and put it on top of this one and you get that they superimpose. No, the hydroxyl group will be this side, okay, but for this one it is on the right, but this one is on the left, okay. Now you get that molecules, okay, that are having the same structural formula, okay, but they are mirror image of one another and they are non-superimposable, then those ones are known as enantiomer. Okay, they are the ones that are known as enantiomer. So these ones here are enantiomer, in that they are mirror image of one another, but they cannot be superimposed, in that you cannot take one and put it on top of the other. Okay, they are known as enantiomer, of which in Greek they say this is enantio. Okay, enantio in Greek it means enantios means opposite. Okay, they are opposite. In that you see they are opposite. This and this they are opposite. Okay, so these ones are known as enantiomers. Then also there is something that you should also get to know. You get to know that if we have a carbon atom, okay, like now this one over here, we are having a carbon atom that is surrounded by 4 different functional groups, okay, by 4 different functional groups, then that carbon is known as a chiral carbon, okay. Like now over here we are having a chiral carbon, okay, the chiral carbon that you are having over here. Why are we saying it is chiral carbon? Because we get that on the top it is having the aldehyde functional group, okay. On the top we are having the aldehyde functional group, but now on this other side we are having the hydroxyl functional group, okay. On this side we are having the hydrogen, okay, and on the downper part we are having alcohol, okay. Have you seen that? So this carbon over here, it is surrounded by 4 different functional groups, and now that makes it a chiral carbon, okay. Chiral carbon is the carbon that is surrounded by 4 functional groups, and maybe we can relate that to this, okay. So if we check on this one, how many functional groups is surrounding this one? We are having a ketone here, right? And we get that this one over here and this one are similar, okay, and since they are similar they just make 1 functional group. So this one over here is surrounded by 2 functional groups, hence this carbon over here, it is not a chiral carbon. A chiral carbon has to be surrounded by 4 functional groups, like now the one that is described over here, surrounded by 4 different functional groups, but this one is surrounded by 2 functional groups. So we have number 1 is the ketone functional group, and now these 2 are similar, right, making it a single functional group, alcohol. Yeah, so over here this one is not a chiral carbon, but this one is a chiral carbon, okay. That is a chiral carbon, okay. Yeah, and you should also get to note that the trioses, they are very important sugars, okay. They are very important sugars, and that is said that the trioses are very important. This is because other sugars, okay, like now we get the tetrose, the hexose, okay, the pentose, okay, they can be generated by from the trios, okay, from the trios, in that you will just add the number of carbon atoms as we go downwards. Because the trios is having 3, but now when we add, if you want to make it a pentose, okay, we'll just have to add 2, so it will be having 5 carbon atoms, okay. So get that the other carbon atoms, the other sugars can be generated from the trios, okay. And now what you should know that as long as now we are having the trios, we are having the D, like now we are having the D trios and the D glyceraldehyde and the L glyceraldehyde, okay. We get that the ones that will be on the D side, all of them will be D sugar, okay, will be D sugar, but the ones that will be on the L glyceraldehyde, all of them will be L sugar, okay, L sugar.